Okay. Let me see something. I don't need landscapers in the background right now. This is horrible. Perfect. Thank you for the feedback. How is everybody? By the way, there's about a 10-second delay when I speak, so whenever I say something, it gets back to you 10 seconds later, so there might be some awkward silence in between. Awesome. Glad to hear you're doing well. No problem. I can imagine you're stressed. That's why I'm here. I mean, like, I'm getting by, you know, to put it lightly. This is a nice little distraction. I can use it. I'm really happy to be here today. Yes, it will be recorded. So when I do this live stream, it's going to get archived on YouTube, and you can just revisit it whenever you would like. So yeah. I apologize for any distractions in the background if you can hear landscapers. You know, it's not, I definitely don't want them here right now. This is just legitimately the worst timing. Ugh, this is such a joke, I swear to God. I'm so sorry. We have 16 people here, okay. Last year when I did this, I think I had about 185 people in the Zoom session. Speaking which, I'm really sorry I couldn't do this over Zoom and make it an actual Kahoot. You know, my Stony Brook account went poof. So, unfortunately, I can't fit more than 10 people into a Kahoot kind of, you know, game. Yeah, Kahoot game. Instead, I'm going to go for my diamond play button here. I guess everything works out in the end. In another life, I was a YouTuber. Well, try to be one. Try to do too many things at once. Yeah, I know. I graduated in summer of 2021. I know that I'm ancient. Am I going to share the PowerPoint with you? I can see if I can do that. I'll try my best. Last year when I did this, when I had my Stony Brook account, I had a Google Drive and I was able to share everything. PowerPoints, including for the review sessions per midterm. Things are a little bit more complicated now. I'm going to lose my sanity. These landscapers are right outside my freaking green room. And it looks like it's going through the microphone too. One thing you guys can do while you wait is that you on your sheet of paper, if you have like lined paper. Oh, it's not that bad. Okay, interesting. I mean, I can't complain. Great. On your lined paper, if you have it, you can number 1 to 50. For your answer choices, this is going to be a 50-question review. And you can check off the answers that you get right and come up with a little tally. I'm going to avoid spoilers throughout this presentation. I'll tell you how people seem to do after the fact. Perfect. Very glad to hear. I guess this justifies that I really am my worst enemy. But really, I feel like we are all our own worst enemies at the end of the day. We all have our insecurities. Two people here. Okay. For those of you who have just joined or are coming in right now, how are you guys doing? If you're not doing all too well, it's totally fine. We all have our bad days and our good days. And when you think about it, sometimes when you're upset, that means that you must have been really happy before then, that it can just bring you down that much, you know? Is there a Kahoot code yet? Ah. So what happened was that when my Stony Brook email shut down, I lost that good Kahoot plan. It came with the Stony Brook email, so I can't host more than 10 people at once, so I came up with a little alternative. And this is recorded as I'm speaking. So what's going to happen is this live stream is going to get archived to YouTube. And you can revisit it whenever you want. At the end of this, if everyone lasts, as long as they do, I'll also have a feedback form for you to fill out. It shouldn't take terribly long. I'm going to be here for about 3.5 to 4 hours, so just 3 minutes of your time, 3 to 5 minutes, would really mean a lot to me. I'll push it out through the calendar invite that I sent. I'm doing a great job. I haven't even started yet. What are we talking about here, man? Come on. Thank you, though. I really wish that I can do this in an in-person setting. It would be much more interactive, but it beat like that. Javits under construction, not within my control. You know? No problem, Tabby. It's always a pleasure. Just typing in the group me. I know it says here the start time is 1 o'clock, but obviously I do not anticipate that everyone's going to get here at 1 o'clock. Usually a bunch of people coming in late. Those of you who got here early is on time. You're definitely doing it right. So I'll really start around like 105, let's say. If you're just getting in here, sorry about the landscapers in the background, if you do hear them. Some people said it's not that bad, but I'm going crazy on my end. If you can just, on a sheet of paper, just number 1 through 50 for your answer choices. And check off every question you get right. This way you can monitor your progress and what you need help with. The only spoiler I will give is that I've structured this exam so that it's 25% finals material, like the new stuff, and 75% everything that came before finals. So it is a cumulative mock exam. Could you change your gain volume in OBS to remove the landscapers? I tried to do that. It wouldn't let me change my volume. It stuck me at sample rate of 48. I don't know what the heck that means, but yeah. I don't need this right now. Necessary censorship there. I really don't need landscapers in the background. I'm really sorry. I did not plan this at all. Alright. Start in a few minutes while the stragglers pile in. By the way, I'm still dedicating my diamond play button to 129. I had that discussion in their group me. So yeah, I didn't forget. What is the Kahoot code, if there is any yet? Okay. So, because I lost my Stony Brook email, I don't have a very good, Kahoot account. They gave me the free plan. I lost the one for students. So I can only have 10 people in a room at once. Sadly. And I don't think it's fair that only 10 people get to play, so instead I've got a little workaround. I'll share it in the chat once 1305 comes. And I'll verbally speak it. I don't want to make these adjustments either, trust me. Yeah, no problem, Nicole. No problem. Could the PowerPoint be shared? I'm going to see what I can do. So last year when I did this, what I did was that I had a Google Drive. I shared all of my materials there. So I had PowerPoints for exams 1, 2, and 3, midterms, and for finals, actually, finals material. And I also had the live recording for the Kahoot that I did last year and the PowerPoint. I'll see what I can do because my Stony Brook email disappeared on me. I'm ancient. I graduated in 2021 summer. So yeah. And I have answered this. It will be recorded and archived on YouTube, so you can revisit it whenever you would like. It's never going to go anywhere. Recording for this review be shared. I literally just answered that. I know latency though. I hope that helps you guys. But with all of this being said, I believe that we are ready to get the show on the road. So let's rock, baby. So I did not do any of these presentations by myself, and I'm the kind of person I give credit where it's due. So I just listed out some of the TAs that have made all of my reviews possible in the past. Love them. I had some rules written here for when I was doing this as a Kahoot style. So rule 1, there are no rules. That's the joke. Actually, if you get where I got that from, then more power to you. It's from the Alvin and the Chipmunks movie. I don't know why I still remember that line, but I did. And mic muted does not apply in this case because of the modifications I had to make to this presentation. And while we're doing the review session, you should really only be using the chat when you're not answering a question. This is supposed to be like an actual exam that you're taking. So don't discuss anything, just solve it on your own. If you have any questions, I'll give you the floor. You can message us. You can message me in the chat. Appropriate username, don't worry about that. Not Kahoot once again. Number 5, if you have your reference table out, that would be great. Definitely need that. Formula sheets, your calculator, and of course your pencil and paper. So when it comes to the pencil and paper, what you're going to want to do is number 1 through 50. And you're going to want to write your answer choices down and mark it correct and incorrect as the presentation goes. This way you can track your progress as you're going along. I'll just ask people how they're doing at the end. Feel free to shout it out. It's okay if you didn't do that well. I'll talk about that later. And really, have fun. This is meant to be a casual, relaxed review style, you know, where I just chat into the screen a little bit, ramble, and you all answer some chemistry problems. So, you know, take it seriously, but not too seriously, basically. Enjoy the ride as you go. And now for the first question, I'm going to start the timer for 1 minute. Wow, this latency is actually pretty terrible. My God. Okay, that was 1 minute. And so your answers are written down. Don't change anything. If you change your answer now, you'll just be cheating yourself. And so the answer to this question would be V square. So it is 2 and 3. And so when it comes to homogeneous mixtures, all of the particles inside of the mixture are distributed uniformly throughout the sample, And in general, the particles are on the smaller spectrum. When it comes to heterogeneous mixtures, we can see the individual components as separate substances. So, for example, when you think about a cookie, that's, a weird example, but, you have the chocolate chips, you have the cookie part, the dough. You can see everything separately. And solutions are homogeneous mixtures, and they contain a solvent and a solute. And so the key thing that you want to note about solutions is the word dissolves. And so with that being said, we can say that dry air is a solution because nitrogen is in the greatest presence. It's about 70%, I want to say, maybe a bit less. And we have other atoms dissolved in it in smaller quantities. So for example, we have oxygen, which is about 21%. We have hydrogen. And we even have some compounds dissolve. So, does anyone have any questions? I'll just sit here and wait awkwardly because we have quite the audio and video delay here. I'll wait a good minute. I don't believe that there are any questions. If you have any, then you'll have to ask me later. But I think that we are ready to move on to question 2. So I will give you a full minute for this one. I asked that first question deliberately because you're going to see some conceptual questions on your exam. Okay, that's 1 minute. And so, with that being said, I am going to progress to the solution. And so the answer is circle, so that would be 4 significant figures. It's important to actually solve the math problem here, because you will see that you'll actually need every single, well, specifically with the first operation, the multiplication, you'll need every single digit. And so we have 5.70 times 16.90. And so 5.70, that's 3 significant figures. 16.90, that's 4. We're going to want to take the fewest number of significant digits. And then from there, we're going to use 96.3, the 3 significant digits. And we are going to plug it into the addition step. So 96.3 plus 7.2356, whatever. And now when it comes to significant figures for addition, we're only going to want to use the significant digits after the decimal place. And so there's 1 after 96.3 and 4 after 7 point whatever. I really don't care at this point. And so we get 103.5656. And maintaining the 1 decimal place after, we're going to end up with 4 significant figures total, which is 103.6. We round it up. Does anybody have any questions? have a couple people asking to join. Let me send them this right now. I thought following zeros after the decimal didn't count as significant figures. They do. So when it comes to the significant digits, the ones before do not count. Like the zeros leading up. So like let's say we have like 0, 0, 0, 5.70. Those leading zeros do not count, if that makes sense. But the zeros after the fact, they do count. They do. Oh, I had volume on my computer and I was just sending the link over to somebody. My bad. That was awkward, epic failure. The Kahoot code, so with the Kahoot code, we are not doing Kahoot because I lost my Stony Brook email, which allowed me to host more than 10 people at once. I'm sorry about the inconvenience, but you'll have to list out everything 1 through 50 and give yourself a check mark for every question that you get correct. I hope that answers your question. If not, you can follow up. I apologize, I'm still getting emails. I think I'm ready to go on to the next question, though. I hope that, Mia, I hope that I answered your question properly. If not, then you can correspond with me after. I'm going to move on to the next question. I'm moving a little bit slower than I would have liked. The delay is what is killing me right now. No problem. 0.00012, the zeros before one is not counted. Dan, actually, now that you mention it, something like that, you can just do that in scientific notation. So you can do 1.2 times 10 to the negative fourth, and that would be 2 significant digits. Very valid point. I should have actually brought that up. I was just... What's the word? Tunnel vision. I had tunnel vision while answering that one question. Okay. So that is 1 minute. I'm going to proceed to the solution. And so the answer would be 5.3, circle. And so now if we're going to be looking at this, the smallest tick mark here is 0.5. And so it's it is, what do you want to call it? So it's one certain digit, one uncertain digit. That's what I was trying to explain. Because we're certain about the 5 here. We're kind of stuck in the middle. And if we were to say like 5.25, for example, that's like saying you're certain about the 5.2 part and you're uncertain about the 0.5. And so we want to exercise a little bit of caution, play devil's advocate. And so we can just say 5.3 is a reasonable estimate of the length of the red bar. Does anybody have any questions? Oh, welcome, Dr. Amaranti. I'm glad you can be here. I will take it that there are no questions. I'm going to proceed on to the next question. I'll give you an extra 30 seconds for this one while you weed out for the correct answer. Oop. The timer is complete, so your answers are locked in. I'm just answering a chat. Sophia, for number 3, wouldn't be a time that we round to 2 decimals place. And so for that, if we had like 0.1 tick marks and it were right past let's say it were 5.25. If there were tick marks for every 0.1, then we can say for certain that it's greater than 5.2. But we cannot say for certain that it's 0.25. And so that last digit is uncertain, and so we can just say 5.25. Like, in that case that there were a 0.1 tick in between everything. I hope that answers your question. I'm going to go to the answer for this, which might have been somewhat obvious because these guys are kind of marked as spelled incorrectly. That's why I wanted to present in full screen, but it wasn't letting me. So the correct answer choice for this one would be A. So tin for bromide. So if we look at that, we have the oxidation state for tin correctly labeled. And bromide is also correct. We don't need to specify anything for the tin, so this is good. And that leads me to why answer choice diamond is kind of bad. Oh, you're very welcome. So tin diphosphate, that is garbage right there. First of all, there is no oxidation state listed. And secondly, you do not need a numerical prefix for tin. For choice C, circle, aluminum fluorate. Fluorate isn't even a thing. If we said aluminum fluoride, that would be correct. Speaking of which, for the second answer choice, the correct answer would be tin something diphosphate. I have it here. Tin 2 phosphate, diphosphate. No, it is phosphate. Oh man, I'm just like... And for choice D, square, iron 2 oxide is incorrect because the oxidation state for iron would be +3, not 2. I have that written here. Does anybody have any questions before I move on? This audio delay is absolutely killing me. Awkward. Cut. Oh, God. I'll take it that there are no questions. I'll go on to number 5. I'm going to put on the timer for 2 minutes, and let's get to work. Aluminum does not get a Roman numeral because it always has a charge of +3. There is no ambiguity, so you just say aluminum, whatever it was next to it. I'll remember it. Aluminum fluoride it was. I hope that makes sense. If not, you can always ask questions. All right, time is up for this question. So I am going to go over to the solution. And so the answer here would be square, FeO. And so for this, we're going to want to find the number of moles per each atomic species. And from this, we can gather the empirical formula. And so the molar mass for iron is 55.45 grams per mole. And so if we use 77.5 grams times that, we can get 1.40 moles. Applying similar processes for oxygen, we get 1.41 moles, and the molar ratio for both of these species are 1-to-1 ratio, basically. And so we can just say that the empirical formula for this species is iron 2 oxide, FeO. Does anybody have any questions? I am really loathing the fact that I do not have Zoom right now. This delay is unbearable. I think I am ready to move on to the next question. I hope that you all are too. I'll give you guys 3 minutes for this one. I am starting the timer right now. By the way, did you guys pay the $50 for the review session? I'm just kidding. I would never do that. I love what I do. So because we get 1.40 and 1.41, we basically just round it down to 1-to-1. Yeah, we don't need to be exact like that. It's 1-to-1 basically. What if it wasn't a one-to-one? Then in that case, it's just an empirical formula. And so for like 2-to-1 between iron and oxygen, let's just pretend that's not possible. Then it would be Fe2O. So basically, the ratio determines the subscripts for each of the atoms. I cannot make this a Zoom call because after 4 minutes, it gets cut out, sadly. Okay, that's 3 minutes. I'm going to proceed to the solution now. So the answer for this one would be C, circle. And so first, we're going to want to find the molar mass of this species, potassium dichromate. And so if we just take the number of moles of each of these guys and multiply it by their mass, we're going to get the molar mass. And so from here, we can find the number of moles total of potassium dichromate, which is about 0.2680 moles. And then from here, they are asking for the number of atoms of chromium, I believe. Yes, chromium. And so from here, we're going to multiply this number of moles by the number of molecules, Avogadro's number. And so the moles cancel, we get molecules. And then there are 2 atoms of chromium per molecule of potassium dichromate. And so we get our solution of 3.227 times 10 to the 23rd atoms using this unit conversion. I will wait here in case anybody has any questions. I know that this was very computation heavy. I'm going to go over to the next one. And this one is going to take about 3 minutes. So you turn it to molecules before converting it to atoms? That's how I do it. So we get moles, we cancel out moles for molecules, and then we cancel out molecules for atoms. That's definitely the best way to do it. Step by step, you can actively watch the units getting canceled to get to atoms, I think it's perfect. I think the landscapers left. Woohoo! Next thing I gotta worry about is my dog barking. I do send dog pics in case anyone is interested. All right, 3 minutes have expired. Let me go to the solution. And so for this one, the answer would be diamond. And so first, we're going to want to find the empirical formula. And so we went through this earlier. So we have a ratio of 1 to 2 to 1 between carbon, hydrogen, and oxygen. I'm just going through this fast because we've done this, and I've already waited quite a bit because of the delays in audio and video. So we get CH2O as the empirical formula. However, they are asking for the molecular formula. And so we are going to have to find it by finding that sweet spot. And so the mass of CH2O is 30. So what I do is I establish this inequality to find the subscript to multiply each of these species by. And so I find that if we divide 30 on both sides, then we're going to get that n is equal to 5 because it's an integer. And so we are going to multiply CH2O all by 5, as in the subscripts. So there's 1 carbon, 2 hydrogens, 1 oxygen in the empirical formula. Multiply by 5, we are going to get C5H10O5. Any questions? Ask now or forever hold your peace. I think I'm going to go to the next question. This one, I'll give a little bit more time. Combustion analysis, everyone's favorite type of problem. Can you explain the last step again? And so, yes, of course. So the 30 that I put in that inequality comes from the mass of the empirical formula. And they say that the mass of the final product is between 140 and 160. And so if I were to establish that inequality divide by 30, then I'm able to get that the subscript is multiplied by 5 for each of the atoms. I hope that answers your question. This is exactly what I don't need right now, is my dog barking. That's 4 minutes. And now for the solution to this problem, everyone's favorite kind, we're going to get answer C, which is a circle. And so for this one, we're going to be taking the mass of the carbon dioxide for carbon and finding the percentage or the weight of carbon, specifically in CO2. We get 0.401 grams. And we apply similar processes for the weight of hydrogen in H2O. And we're going to be getting 0.0251 grams. And now oxygen is going to be appearing in both carbon dioxide and water, so we're going to have to do things a bit differently. And so we're going to be taking the mass of tetraphtalic acid, however you say it, don't really care, and subtracting the weights that we have calculated here, and we're going to be getting our mass of oxygen. And now we are going to be finding the molar ratio for carbon, hydrogen, and oxygen. This is kind of redundant from what we were doing before. They're only asking for the empirical formula here, I believe. Yes, they are. And so we are going to be getting C4H3O2. This is definitely not one of my favorite problems either. It's not exactly intuitive. Do you have any questions? I'm going to go on to the next problem. If you're still typing it, I'll answer it after. Already, we've had quite some time go by and we're only on question 9 out of 50, so the struggles of using YouTube Live. All right, it's 3 minutes gone. Now for the solution, we are getting answer D, the square. And so now, if we were to look back at the original equation, we would find that phosphorus only occurs once on both sides. And so it would be best to balance that first. If we were to do a little count up of everything, we would find that we have 2 phosphorus on the left from the PO4, 2, phosphate 2. And then we have tetraphosphorus on the right side, P4. And so by multiplying the left side by 2, the calcium phosphate, we're going to have 4 phosphorus. And so now that kind of throws everything off too now, because now we have 6 calcium on the left. We can balance that by giving calcium, I think that's silicate. We give that a coefficient of 6. And now, oh no, our silicon's out of balance. To balance that, we're going to need to give SiO2 a coefficient of 6. And now we're only going to need 10 more oxygens. We're going to need 10 oxygens on the right side now to balance out the oxygen. That was the weird one because it, as you can see, it reoccurs here. We have it twice on the left, twice on the right. And so now if we balance that out by giving 10 to, I think it's CO. Yes, CO. Then we're going to need 10 carbons to balance carbon. And so now I have the final equation written down below, which corresponds to choice D, square. Any questions? It certainly helps to make a table for the elements as you go along. So as you balance the equation, cross out, write down a new number. I find it very helpful. Let's get a start on question 10. I assure you that not all these questions are 3 minutes long, by the way. All right, time's up. So now for this problem, they're giving us the number of products, the amount of product that we form. They're asking us to get there from grams of sodium fluoride. So let's get this show on the road. So we can use the mass of the reactant, sodium fluoride, and we can use the stoichiometric coefficients and the molar masses for each of the products, or the reactant and the product, to get to the final answer. And so now, first, they are giving us 485 grams of the sulfur tetroxide. And now let's cancel out the grams using the molar mass. And now we're going to have moles of sulfur tetroxide. From here, we're going to be using the ratio of the moles of sodium fluoride to sulfur tetroxide. That way we can cancel out the moles of sulfur tetroxide. And then we can finally get what we're looking for, the mass of sodium fluoride, by just using the molar mass. And so moles cancels, and we have everything in terms of grams, which is 754 grams. It's very useful to practice these unit conversions. Any questions? I'm going to move on to the next one. Another 3-minute question. Come on, man. Everyone's favorite. How's everybody holding up? Doing okay? Not even on the problems, like mentally, are you hanging in there, everyone? If you feel like you could be doing better, not all hope is lost. And I'll tell you why later. All right, time is up. Let's go on to the solution. So the answer to this one would be, that should actually be triangle. Should have changed that. And so to solve this problem, they are giving us the mass of toluene. Is it toluene? Yeah. They give us the mass of toluene. And so there are two naturally occurring isotopes for toluene, and this comes with a significant advantage when it comes to problem solving. So the percentage abundance for each of these two isotopes will always sum up to 100%. They're perfectly supplementary, complementary, whatever. And so we can establish this algebraic expression. So we have the lighter isotope multiplied by x, and then plus the heavier isotope times 1 minus x. And now we distribute out the parentheses here, and we isolate both sides. So we have this and this times x. If we were to solve for x, then we would find that the percentage abundance for toluene-203 is 29.52%. And so given the relationship between these two isotopes, how they always sum up to 100%, we can do 1 minus x for 70.48% toluene-205. Any questions? As a little side note, I didn't do space over here. Space between the equal sign. Oh God, I really want to just fix that right now, but it's just so small. It's fine. Not everyone's perfect. We all know this, especially not me. I'm going to go to the next question now. This one is 3 minutes. Noticing a pattern here? They're not all going to be this long, though, I promise you. Because the next one's going to take 20 minutes. Oh man, I forgot to start the timer. Just kidding. 2 minutes left. All right, time is up. And so now for this question, this is a theoretical yield versus actual yield question. Well, percent yield is the actual term. And so now for this one, we're first going to want to find the limiting reactant. And so for this one, kind of like how in that one of those earlier problems, we use the molar ratios and the molar masses. We're going to be doing that again for both of these species separately. And so whichever reactant is limiting, we're going to be using that one. It's not always going to be a larger number. As in, it's not always going to be, I'm trying to explain it. It's not always going to be the reactant that is larger in mass. That's what I was saying. Not always. That's just something you want to be mindful of. Whichever one where you use the coefficients and the molar masses and it gives you the smaller number, that's the one you use. So in this case, it happens to be the oxygen, which is actually presented in lower after all. And so now from this, we can use the ratio between the actual yield and the theoretical yield to find the percent yield. And so they tell us earlier in the problem that they were able to get 43.4 grams of product from the reaction. In theory, though, from what we've calculated here, we're supposed to get 88.6 grams of tetraphosphorus hexoxide. And so if we take the actual yield divided by theoretical yield and multiply by 100, then we get our theoretical yield of 48.8%. Any questions? I believe that this concludes exam 1 material, and you're in luck because the next question isn't 3 minutes long. I am going to be moving on. Push forward. This one you get 1.5 minutes. If you're afraid to ask questions because you don't want to hold anyone up, by the way, listen, it's totally okay. Just ask. I'll always be here for you all. And of course, any questions that I don't answer on this stream, you can just email me anytime. I'm very approachable, and I'm always happy and willing to help. Okay, so when it comes to posting these slides, I'm going to see if I can do another Google Drive where I share it with everyone who was here today. I'll see what I can do. Losing my Stony Brook email, I don't know if I have the same capacity to do something like that. I'm not sure at this time. All right, time is up. So for the solution for this one would be diamond. And so in this problem, we're going to want to have an equal number of moles of acid and base at the end. And so to solve this, we are going to be using MAVA equals MV, MAVA equals MBVB, where M1V1 equals M2V2. And so we have the number of moles over here for the acid equal to the number of moles over here. And just accounting for the relationship between molarity, which is moles over liters, we are able to get our molarity of 1.13 molar. Any questions? I presume not. All right. This one, also a minute and a half. Let's give it a whirl. I think I made a mistake on the solution for the last problem. I was thinking ahead to this type of problem. Honestly, I was getting too excited. For the other one, you'll just want to calculate the number of moles and find the molarity through moles over liters. I got way too excited for this type of problem. I'm always thinking when M1 V1 equals M2 V2. It's just catchy. I'm sorry about that. All right. And now, here is where we are going to be using. I was getting excited again. I'm just always excited about that one equation. And so we know that molarity is equal to moles over liters. And so for this problem, they are giving us the molarity and the number of liters. And so we are able to get the number of moles from this. And then we are going to use the molar mass to find the actual mass. And so to do that, we just have the grams times moles per gram. And so doing that unit conversion, we're going to be getting our answer of 0.419 grams. Basically, when you think about it, a lot of General Chemistry 1 is these types of unit conversion problems. Any questions? All right, next one should only take 1 minute. I would even put it at 30 seconds, but, 30 seconds feels a little bit too, I didn't want to do it for only like a couple of questions, just felt weird. All right, here we go. So this one, honestly, I shouldn't even ask if anyone has any questions. This one should have been very straightforward. But if you do have any questions, don't feel ashamed or afraid to ask. And so for this one, this is going to be complete dissociation between these two species. NH4 ammonium is considered ionic when it binds. Or actually, I think the proper word is coordinate covalent. You don't have to worry about that. So they're going to completely dissociate from each other. And so 3 moles of ammonium and 1 mole of PO4 multiply by, that's 4 moles in total of ions. Multiplied by 1.6, we're going to be getting 6.4, triangle. And now any questions, just ask. I'll catch up on it. I'm going to move on to question 16. Just typing. All right, time is up. I was just typing in the chat. And so now for the solution. This is what I was getting all excited about. M1V1 equals M2V2. And so the 16 molars corresponds with the acid. Yes, nitric acid. And it's going to be diluted by water. And now water is a neutral species because hydronium and hydroxide are in equal concentration, but it can be treated as a base. That's all that's important. And relative to the acid, it certainly is one anyway. And so now we have this algebraic expression, and we're going to be solving for the volume of the acid. And so if we just divide 2 times 2 divided by 16, we're going to be getting our volume. So it's 0.25 liters. We convert that to milliliters. And so we slided the decimal over 3 places, and we get 250 ml. Any questions? I'm going to move to the next problem. This one is also going to be a minute 30. One thing I'm going to do later is when I have the stream archived and everything, I'm going to have chapters for each of the problems. Or I'm thinking about going chapter by chapter for each, what am I thinking? Material. So like exam 1 material, exam 2, exam 3, finals material, that kind of thing. If anyone wants to kind of tell me what they would prefer. All right, time is up. And so now for this type of problem, we're going to want to assign the oxidation states for each of the species. And so if you were to take a little look here, we would find that copper oxide, I think it's copper 2 oxide, unless it has one charge, I don't exactly remember, but oxygen is going to have a charge of -2. Copper is going to have a charge of +2. And so we go from +2 to 0 over here. And so copper is going to be reduced. And so an oxidizing agent is what does the oxidizing. And so in the process, it is going to be reduced. And so from that, we're able to get our answer of triangle, as you can see here. So +2 to 0, copper is reduced. Copper is going to be oxidizing the NH3. Does anyone have any questions? There is some intuition behind the oxidation states, by the way. It comes from the desire for atomic species to share or take electrons. I learned all about it during my MCAT prep, actually. It's very interesting. You gotta wait a few more seconds. All right, next. Oh man, I thought I was done with 3-minute problems. Oh. Ah. Okay, time for the solution. So now the answer to this is square D. And so the first thing we're going to want to do is we're going to want to separate into half reactions. And so in this case, we're going to have tin being oxidized. As a matter of fact, you can think of it being oxidized in the sense that it's actually attaching to oxygen. And we also have nitric acid, and it is being reduced to nitrous acid. Yeah, nitrous acid. No, it's not. It's being reduced to nitrite, my mistake. And we also have water over here. And so now we're going to want to balance these out. And so first, we're going to be adding water to both sides. And so now add 2 H2O for the tin. And then after you add water, then you're going to want to be adding the hydronium ions, the H+. And so now we're going to need 4 of them to balance out the hydrogen. And then we're going to want to be conserving the charge next. Conservation of charge applies in chemical reactions always, along with everything else. And so now here's our balanced reaction down here. And we're going to want to apply similar processes for the nitric acid. And then once we have this out of the way, we're going to want to combine the equations, balance them out. This way we can cancel out the electrons. That's really the main goal, is canceling out the electrons so that we have the conservation of charge that I was referring to. And so now we have the final equation written below. And that corresponds to the answer of square. Do we have any questions? All right, I think we're ready to move on. But what would I know? I don't have, I can't see the audio delay perfectly on your stream. What would I know? This one will take 1 minute. All right. Now the answer to this one is circle. And so now oxygen will basically always have a -2 charge. There are a couple of exceptions, but look at it this way. It's extremely electronegative. It's hungry for electrons. Osmium is less electronegative, and so with that being said, it's going to give up its electrons to oxygen. And so oxygen has the -2 charge. And so we're going to be doing conservation of charge right here. And so between all the oxygens, it's going to be it's going to have 8 extra electrons, and so we want to cancel it out. And so we're going to need a charge of +8 to balance out everything. I hope that makes sense. So -2, -2, -2, -2, +8 to balance it out. If you have any questions about that, you can just ask. This one was relatively straightforward. I kind of want to keep going. it should resurface anyway, the concept of oxidation state. So I don't want to hang up too much on it. All right, time is up. And so now for this problem, we have the answer of diamond. And so this is an ideal gas law question. And so for this one, we have PV equals nRT, which is equal to a constant. And so because it's all equal to a constant, it's always going to be the same number. So we can set pressure, volume, and temperature equal, PV over T equal, before and after. We know that we are going to have a constant temperature, and so we can simplify this expression. We get V2 equals P1 V1 over P2. And now we can solve for the volume, which is 44.33 liters. Now, they say that the volume was initially 35.0 liters. They're asking for the change in volume, and so that's how we get 9.3. It's 44.3 minus 35 is 9.3. In case you didn't know that, just in case. Any questions? All right, let's move on. I just realized something. That I believe that should be for the product C18H3602. Must have been a really small typo, but it doesn't matter for this problem. It probably took me a good 8 hours to do all these slides, at least my share of them, so like, please forgive me. All right, solution time. So now for this problem, we're going to want to find the number of moles of linolenic acid first. And so we start with 10.5 grams of it. Its molar mass is 278.4 grams per mole. That's how we get the number of moles. That's simple conversion. And so now we're going to want to find it in terms of moles of H2. And so now there are 3 moles of H2 per mole of linolenic acid. And now to find the number of liters, we're going to want to use the number of moles. And at STP, there's always, at STP, 1 mole of gas will always occupy 22.4 liters. It's just a magic number that you have to memorize. It's proven through PV equals nRT at standard temperature and pressure. And so you get 2.53 liters. Any questions before I move on? Okay, I think I'm ready to go. This one will only take 1 minute. All right, time is up. This one should have been 30 seconds. This one, the answer is D, square. And so now for this, kinetic energy on average is just 3/2 RT. So all it really depends upon is temperature, and all these gases are at the same temperature. So if you ended up picking hydrogen as having the highest average kinetic energy, I understand what you did, but you're thinking of root mean square speed most likely, which is URMS equals square root of 3RT over M. If you have any questions, just ask me. I think we should just go to the next one. This one was straightforward. All right, that's 4 minutes. Now for the solution. One thing we should establish immediately is that the heat lost by the nickel is equal to the heat gained by the water. The pleasure of one is the pain of another, I suppose. And so we know that Q equals mc delta T, which is equal to a constant. And so we're going to want to be conserving the heat here, as in the balance of it. And so we have the mass of the nickel, the heat capacity of the nickel times the change in temperature of it, and it's going to be equal to the negative of the mass of the water, the heat of the water, and the temperature change of the water. After all, we have to remember that the heat loss is equal to the heat gained. That's why we're getting the negatives here. And so now if you're just to do the substitution, by the way, we get the 100 grams here using the density. If we just do the substitutions and we algebraically solve for TF, we are going to be getting 39.6 degrees Celsius. It doesn't matter here, kelvins or Celsius, because ultimately we're only performing subtraction with these and it's kind of evening out. If you're familiar with like ratio interval data kind of thing, it makes more sense. And so now the final temperature is going to be equal for both of these species, the nickel and the water, because that's how they are at equilibrium thermodynamically. If anyone has any questions, let me know. I'll wait a little while because that was a bit of a handful of a question. It was a bit long. Okay, I think I'm ready to move on. And I think you are too. This one shouldn't be too bad. All right, that's time. Now for this one thing we have to keep in mind here is that when it comes to total pressure, I believe it's Dalton's law it's called, the sum of the partial pressures is going to equal the total pressure. And so if you want to just take a shortcut to find the partial pressure of oxygen, we can just find the mole fraction. And so we find that there are 6 moles of gas total and 2 moles of oxygen. And so we have 1/3 mole fraction, and partial pressure is equal to the mole fraction times the total pressure. And so from this, we're able to get 300 millimeters of mercury. I think I'm going to move on this one, because chat seems to be pretty okay for the most part. And if you have any questions, though, once again, please just reach out to me. I'll be here till the bitter end. But in the end, it doesn't even matter, said Chester Bennington. I promise you, though, you won't try so hard and get so far, and in the end, it won't even matter. That will not be the case. You can do this. Sorry about my dog barking. Quiet. Quiet. All right, now for the solution. And so for this one, we are going to be manipulating the individual heats of formation here, delta H. And to do this, firstly, we're going to want to get FeO on this side. To do that, we have to change the negative. We have to negate negative 644. And we have 2 moles here and 1 mole in the product. in the total equation, the net equation. And so we're going to want to half that. And we're going to do the same exact thing for Fe2O3. And so negative 1/2 times the delta H. And now for the product in the net equation, which is right here, Fe3O4, this actually lines up perfectly with the net process. So you don't really need to do any manipulations whatsoever. And so we're just going to take the sum here, and we get plus 79 kilojoules. Any questions? Okay, now We've got exam 3 material. This should be relatively quick. By that I mean pretty quick. Okay. Solution time. And so now the answer for this one would be A, which is triangle. And so one way that I like to see this type of problem is that when we have, so the relationship between energy and wavelength is E equals hc over lambda. And so as we have a much longer particle, that means that it's going to be much lower in energy, because when we have the numerator, it's approaching infinity. That means that it's going to just approach zero, if any of you are familiar with calculus kind of thing. So I'm kind of explaining it here too. And so longest wavelength, lowest energy. This is the longest wavelength. And so it's going to have the shortest energy. Shortest wavelength, excuse me. Any questions? Okay. Wait, you got excused? Can I re-explain? Yes, I can re-explain. Sure. Most definitely. So when it comes to the shortest wavelength, it's going to be very high in energy. And so when it comes to and so the energy here is very, very high. I think I'm explaining it better now. Definitely. So the energy here is very, very high. We're going from n equals 1 to n equals 5. And so in doing so, this is the largest change in energy here. That's going to correspond with the shortest wavelength. If you think of it in terms of E equals hc over lambda, so the energy is getting very large. And so as energy approaches infinity, that means that the denominator approaches zero, actually. I had it completely inverted, my explanation. And so if you want to do it in terms of lambda, that would mean that we would have very high energy on the bottom. And so this is the highest energy, approaches infinity, wavelength approaches zero. I really had it right both times, actually, my mistake. I hope that makes more sense to you. It's kind of some calculus involved, some critical thinking. But I think that it really explains a lot. It's very helpful to think that way. And so I am ready to move on. If you have any further questions, then feel free to ask once again. This one should only take 1 minute. All right. Now for this next one. The correct answer here is D, diamond, square. Well, D starts with diamond. Diamond starts with D. Yeah, yada, yada, yada. And so now for the first one, N refers to the principal quantum number. And so they're saying 3p. And so the number in front, 3, that corresponds with N, the principal quantum number. Azimuthal quantum number, L, also known as angular momentum, it's going to be representing the subshell. And so we have SPDF, S is 0, P is 1, D is 2, and F is 3. And so if we have 3p, the p corresponds with L equals 1. When it comes to the magnetic quantum number, it's going to range from negative L to positive L. And so if L is equal to 1, then it means that L can be negative 1, 0, or 1. It must be an integer to be completely clear. And so when it comes to a 3p, it means that we can have negative 1, 0, 1. So n equals 3, definitely. L is definitely equal to 1. And ML can be negative 1. I'm going to move on to the next question. Another principal type of question. Okay, time is up. The answer to this one would be B, diamond. And so now basically the wave equation, the solution just gives us the meanings of principal quantum number, angular momentum, magnetic quantum number, and spin magnetic quantum number. And so really, I have the meanings listed here. And so principal quantum number, that's referring to the number of shells, and it gives an estimate, a rough size of the orbitals. So for example, n equals 1 is smaller than n equals 2. And now angular momentum here has to do with the shape of the orbital and the subshell, and that is where we get the answer. It's a very theory-based question. There's always a chance that they can ask something like that, so I might as well, prepare you that way. It's not all going to be quantitative. Oh God, you gotta be kidding me. I can hear the bus pulling up outside. It's right near my house. And my dog's probably gonna start barking soon. Oh God. Never mind then. Not exactly a bad thing that I was wrong. Okay. Now, for the solution to this problem, the answer here would be triangle A. And so now we know that we like to usually fill up in order of the subshells. So like, for example, 1s, 2s, 2p, that kind of order. However, there are 4 exceptions that you should take note of on the periodic table. I don't have my periodic table on me right now, but it's chromium, the element right beneath it, and then there were 5 spaces to the right of those 2 elements. Those are the exceptions. It has to do with the minimization of repulsions. The electrons can actually jump only one time. Don't worry about that part, but just know those 4 exceptions. And so in the ground state, chromium would have an electron configuration of argon 4s1, 3d5. However, when we take away 1 electron, we're going to be taking away from the 4s1 first. Why is it 3d, not 3d5? Oh, 3d5, not 3d4. I think this has to do with the repulsions that I was referring to earlier. I can't get the exact theory behind it at this very moment, but you just need to know that they're going to take away from 4s before they take away from 3d. I'm really sorry that I don't have the very best answer to your question. If anyone has any others, then of course, get in touch with me. I'll see what I can do. But for now, I think we should move to the next question. Just know the 4 exceptions and know to take away from 4s before 3d. All right, time is up on this question. And so now the answer here would be triangle or A, magnesium. And so when it comes to the ionic trends, as we go up and to the right for, what's it called? What was it called again? First ionization energy. As you go up and to the right, it's going to be increasing. Just think about it this way. An atom like fluorine wouldn't want to be losing any electrons. And so if we were to look at the choices that we were given, we have magnesium, potassium, calcium, and barium. And so now we can kind of cut it between, actually, no, I'd say like magnesium is a very clear winner here. Magnesium is in the third row. Potassium is in the fourth. And so is calcium, actually, and barium is even below all of those. And so this one is furthest up. And so just from that alone, just being in the third row, we can kind of just say like that's the answer. There isn't really a close second. If you had another element that was in the third row with magnesium, then you would have to go by the position left or right. And in that case, whichever one is furthest to the right would have higher ionization energy, unless there are some exceptions due to electron configuration. I'm going to move on to the next question. All right. Now the answer to this one would be A, triangle. And so now all these ions, they all have a total of 10 electrons. They all basically have two shells for that reason, two filled valence shells. And so from here, we're going to want to consider the ion with the greatest charge to have the smallest radius. And this is due to the electrostatic interactions. Look at it this way. Aluminum will have the greatest number of protons at the center. They're not going anywhere because they're held together by the nucleus. And so we have 13 protons, 10 electrons. Those protons are going to be pulling the electrons closer together. And so for that reason, we can say that aluminum plus 3 will have the smallest atomic radius. I hope that explanation makes sense. I was able to explain it theoretically, like how it works. If you have any questions, let me know. We must push forward. Thank you to everybody who has been here from the very beginning to end, by the way. All right. Next, solution. Now the answer to this one would be diamond B. And so now, if you're to draw the Lewis structure for PO4 3-, then we would find that we would have 32 valence electrons because we have 5, 6, 6, 6, 6, and then plus 3 because of the -3 charge. And so now we can draw in the single bonds from phosphorus to oxygen. And so we lose 8 valence electrons from 4 single bonds. We're left with 24 now. If we were to draw the electrons along the outer atoms, which are the oxygens, then we would have none left. And so the significance of this would be that we don't need to draw any electrons around the central phosphorus. And so now we can balance out the formal charges by drawing one double bond. And so now from this, we will have phosphorus without a formal charge and one oxygen also without a formal charge. Originally, we would have had 4 minuses and 1 plus, but now we've just kind of stabilized things a little bit. And so now we can find the oxidation state for phosphorus. And so now we have 4 oxygen bound, and we have 1 plus 3 to balance out. And so now we have a +5 charge. And really, we can do some process of elimination here to get our answer. So one way to see this is that a formal charge of 5 is very, very bad. Never going to see that. And really, phosphorus must have a positive charge if oxygen has a negative charge when it comes to the, oxidation state. Because we know that oxygen is more electronegative than phosphorus is. And really, none of these other answer choices really satisfy that. Like, if we look here, formal charge of 0, 0, that's fine. 5, 5, that's garbage. Cross those out. Left with 2 choices. Phosphorus would not have an oxidation state of -3 because we know that oxygen is usually a -2. It just wouldn't make sense. So that's how we can do some POA to get there. We're going to be going through this type of thing a little bit more throughout the PowerPoint, so I think we should just keep going. This one will take 4 minutes at most. As long as I'm here, that is. Once I'm done with this presentation, you all can, do this on your own. Take your time, no time pressure, and see how you do. Retest yourself. Retest and reassess. On the bright side, we're about 2/3 of the way there. That is bright side if you don't enjoy chemistry and you're not having fun. I hope that I'm not too boring. Sometimes it's just one of those moments where I'm just like, I promise I'm not boring, and it's just like, that's one of the promises I can keep. And thank you all again for just staying here, tuning in. I'm actually up to 12 likes now. Woohoo. I told you I'm going to get the diamond play button one day. I'll redeem myself from my past failures as a YouTuber. I'll make it. I actually went to high school with someone who had he broke 1 million subscribers. His username, his YouTube channel was Pro Pepper. I think it got taken down. He had to reinstate it. I see him at the diner every Saturday morning for the most part. Just a little fun fact that nobody asked for. Oh, there we go. Time is up. And so now this is a bond energy question. As you can see, the answer here is circle C. And we can create these structures knowing the chemical formula for the compounds. And so when it comes to energy, we have energy being absorbed when bonds are broken, and energy being released when bonds are formed. There's a little acronym for this called BARF. I mean, look at it this way. It takes energy to build stuff up. Like, it takes energy to build your Lego castle. Actually, it takes energy to bring it down. Just forget about that analogy. Or pretend I didn't say that. And so now we have one alkynyl bond broken, 2 carbon-hydrogen bonds broken, and 2 hydrogen-iodine bonds broken. And we have 1 carbon-carbon formed, 4 carbon-hydrogen formed, and 2 carbon-iodine formed. And so now we can find the energy that's involved in breaking by just kind of adding stuff up and multiplying. And so we have the alkynyl, we have the 2 carbon-hydrogen, we have the 2 hydrogen-iodine. And this will give us the energy involved in breaking. Repeat the similar processes when it comes to formation. And we get the delta H by doing delta H broken minus delta H formed. And so we find that the bond energy from doing this arithmetic operation is negative 217 kilojoules per mole. I'm getting to that point where it's like hard to explain why things are the way they are, so I just have to show the math. But if I can ever explain the theory behind it, you better believe I'll jump right onto it, you know? If you have any questions, let me know. We shall be advancing to the next question. Oh, shoot, you couldn't see it properly. Here, I'll give some extra time just for that. Timer went off on my stream, but I'll give some extra time. Someone brought it to my attention that they had some trouble reading the, what's it called? The graphics. So that is CLF3, not CLF2. I'm so terribly sorry. What happened was, when I was setting up last night, OBS is just telling me, like, drop your bit rate down to like 1,000 kilobytes per second or whatever. I'm just like, oh, okay. And now this happens. I mean, I guess things are stable now. It's just like, constantly, crud. Constantly crud, yeah. So, yeah, it's a stable stream, but the graphics, it doesn't look the neatest. I'm so sorry. All right. I think I'm going to move on to the solution, though. Thank you for your patience, Sophia. You too. Thank you. I know. And so what you're going to want to do for this problem is you're going to want to start by drawing the Lewis structure for ClF3. And so now if you just employ the same methodology that I was describing earlier, 28 valence electrons, you can do that quickly because ClF3, it's 4 halogens. And so now you have 28 valence electrons. If you draw the single bonds, you have 22 left over. You then draw the electrons around the outer atoms, 6, 6, 6, so minus 18. You have 4 left over. And then you have 4 electrons that you can draw around the central atom. You're allowed to do it because Cl is in the third row. It has the subshells that are available to allow it to occupy the, allowed to expand the octet. That's the best way to say it. And so now we have 3 bonding pairs. So that's the Cl bound to fluorine 3 times. And then 2 non-bonding pairs coming from the 2 pairs of electrons. And so now from this, we can get the trigonal bipyramidal, yep, that's how you say it, electron geometry. However, we also want to consider the molecular geometry because we have the interactions between the electrons that are just shifting things around. And so from the chart, we are able to get that we have a T-shaped molecular geometry, and the lowest angle associated with T-shaped is 90 degrees. In theory, at least. There are some repulsions that will slightly minimize that angle. It's just amazing how interconnected things are, Like, this stuff is actually very interesting to me. I know that you all just want to, get out of here. But, I hope you emerge from this loving chemistry a little bit more. This isn't just about solving problems. I'm trying to get some understanding in too, I hope that I'm somewhat helping with that conceptual piece, that theoretical piece that's sometimes missed in class that they don't always have time to discuss because, oh, we got things to do, man, let's get the show on the road. Let's go. Let's get out of here. We only got 15 weeks. Rant over. You have 5 minutes for this one. I don't know if any of you have watched The Room, but you know who else has 5 minutes? Denny does. I'm sorry I had to. You want 5 minutes? Well, I've got 5 minutes. Okay, that was 5 minutes. All right, now solution to this one BC circle, and that would be IF5, yes. And so now you're going to want to draw some Lewis structures for each of these molecules. It's going to take a while, should have, and what you will find is that ICL4, it's square planar, it has that SN6, Stark number 6, 4 bonding, 2 non-bonding, 4 bonding and 2 non-bonding pairs, and NH4 plus, that would be tetrahedral, so that would be 4 bonding pairs, no non-bonding pairs. IF5, that would be square pyramidal, that would be, I actually didn't, I was doing this in my head, I wasn't writing it down, but what you will find ultimately is that when you take the molecular geometries into account, you would find that IF5 is polar. Look at it this way. We have the central molecule, we have the outer molecules. There is a significant electronegativity difference, and so there's going to be that dipole moment constantly throughout the molecule. And by the way, RnF2, that would be linear. It has 2 bonding pairs, 3 non-bonding pairs. This is the kind of thing you're just going to have to memorize. Sadly, it's not exactly, you just have to memorize it, the table for all of the geometries. I don't think there's really much I can do for you to help you memorize it. I don't really have any mnemonics, but yeah, if you had some trouble with this kind of question, then look back at that chart that they provide you in class. Now, next one, we've got hybridization. This will be 2 minutes. Starting now. Is everyone having fun? I am. I'm having fun. I really do wish, though, I could have done an actual Kahoot game. I can't say I regret it because it's not my fault, you know? When it comes to regrets, all of you, the only things that you should really regret are the things that you don't do in life. Everything happens for a reason, generally. Okay. Now for the solution. The answer is C, circle, SN4, corresponding with SP3. Now just draw the Lewis structure. We have 5, and then plus 7 times 3, 26. And so you just go through the whole rigmarole again. And so you have the 3 single bonds, 20 valence remaining, and then draw the outer electrons, 2 remaining, draw the 2 on the central phosphorus atom, Because it's in the third row, it means that it can have that extra electrons. It can expand its octet. Part of the intuition behind it, by the way, has to do with how we have like the what's it called? The 3D orbitals. Look at it that way. I hope that's a helpful way to see it. You have 3D. The second n equals 2, you don't have d orbitals available. You only have up to you only have up to 2p, which is total of 8 electrons. I'm digressing. Just know, third row can have the expanded octet. And so phosphorus is one of those atoms. You have PCl3, it has Stark number of 4. We have the 3 bonded pairs. We have the 1 non-bonded pairs, which is the electrons around the center. And when it comes to hybridization, it's determined by steric number only. Nobody cares about bonded pairs, non-bonded pairs. It's just steric number. And so steric number of 4, it's going to be corresponding with sp3 geometry. Okay. Any questions, let me know. I kind of want to speed things along. We still got plenty to do. And now, our favorite, molecular orbital theory. This is going to be a long 5 minutes, ain't it? I know that this question might take a little while. I said I wouldn't really give any hints or talk much related to the question during this, but all I'm going to say is that you can reuse the diagrams. However, not all of them. I know that everybody here wanted to come here to spend 5 minutes on molecular orbital diagrams. It's everyone's favorite. Necessary evil. All right, time is up. Now, I don't have any actual drawings on this particular slide, but I do show off a molecular orbital diagram somewhere else. Basically, I just gave it away. There's going to be another question coming up on MO. So if you're to draw molecular orbital diagrams for each of these diatomic species, so boron, carbon, nitrogen, when you draw them, they're when it comes to the p orbitals, it's going to be pi, sigma, well, pi bonding, sigma bonding, pi anti-bonding, sigma anti-bonding. And so as you're filling them up for these three species, boron, carbon, nitrogen diatoms, boron is going to have it's going to have a net spin because you're going to fill up the species, the sigma bonding orbitals. And once you get to carbon, when it comes to carbon, you're going to have to neutralize the spin before you can go to the next orbital. Come nitrogen, this is going to be where you're going to be filling the one sigma bonding orbital in 2p specifically. I should be clear about that. And now when it comes to oxygen and fluorine, now we're going to be filling oxygen's sigma, we're going to be filling their pi anti-bonding orbitals. Well, not filling. We're going to be putting one in each of the two. And so now we have a spin there. And then fluorine, we're going to be neutralizing that spin. I know it's kind of like weird to explain it verbally, but yeah, I'll be able to show a little diagram on the next problem in the solutions, and it'll come a little bit more together. But the important thing to know, C2, N2, F2, they do not have any net spin. And for this, they are diamagnetic. B2 and O2, they have a spin of +1. And for that, they are paramagnetic. And that's how we get our answer right here. I'm going to withhold questions as we move to the next one. This will be the last question for exam 3 material. After this, we shall be getting to finals material, all new stuff. This might be what you're here for, maybe, I don't know. You tell me. What are all of you having trouble with today? You can just write in the chat, whatever, however you want to communicate with me, email me, I'm always willing to give an extra hand. Everything is an answer. If you're having trouble with everything, I'll see what I can do. You've also got plenty of other amazing TAs. I just happened to be adopted in this case. All right, that's the timer. All right, now here's the MO diagram that I was referring to. And so now if you just draw it out, we're going to be using the sigma first, the pi over here, and then sigma. We're just going to kind of treat this like oxygen fluorine MO diagram. And so now some people like to show the 1s bonding and anti-bonding, but we don't really need to here. And so if we were to fill this up, N minus, that's going to have 6 valence electrons. So as we draw this in, 2s we have right here, and we have 2p right here, 1, 2, 3, 4. We're done with that. Oxygen, same exact thing. And now we can just blend these two together. And now we have the 2s, we have the sigma bonding and anti-bonding filled. Now we just have to do this right here. And so now we have to draw these in, just blend them. 1, 2, 3, 4, 5, 6 bonding. 1, 2 anti-bonding. Again, I don't know why this is. I don't have a great idea of, why chemistry works this way. I just have to talk about this. However, I have some excellent news for those of you taking the MCAT. Once you're done with this class, you probably will never see this again. I don't think I saw it a single time in practice, including third party. So yeah, if you have any questions, let me know. Life? Yeah, totally. Tell me about it, man. My life has been very, very challenging recently, to understate it. Chapter 2, that's the earlier stuff. Got it. Everything understandable. Mentally, I am unwell due to chemistry. I get that. I'm here for you, bro. I've got you. I've got you all. Never letting you go. Man, if any of you've seen that Dahmer documentary on Netflix, please don't go. Just slaps. I swear to God. Am I in med school right now? No, I'm applying. Not gonna lie, I got my first rejection from its school I interviewed for a few days ago. Oh God, it sucks. Like everything's going wrong at once. Does that go for Gen Chem 2 and Dorgo? You're never going to see it again, my friend. I assure you. I'm having so much fun chatting, but we can save the chatting for later. I think some people want to keep going with this review session. That being said, let's go to finals material. But yeah, I don't know what it is. It's just like everything's going right at once, and then everything just comes down. If I don't get into medical school, I'm thinking about nursing or education, either high school teacher or college professor. we'll see what the future has for me. But, I'm really happy to be here right now. I've been down my luck. Something like this, good distraction. I love you all. When it rains, it pours. Very, very true. I received a gift from above, and I had it all taken away from me. That's just how life is sometimes, Why am I laughing? I'm hurting inside. I'm dying. I'm in agony. Oh, God. Anyway, the answer here is C, circle. And so now when it comes to polarizability, it's associated with the size of the molecule. So larger molecules are more polarizable because it has more intermolecular forces. And so now when it comes to CCl4, it's less polarizable. Chlorine is smaller than iodine. And we have similar logic for oxygen versus selenium. So H2O is also less polarizable than H2SE because we have oxygen higher on the periodic table than selenium. However, carbon chains, a little bit special. So we have hexane here, C6H14, more polarizable than butane, C4H10. Has to do with the length of the hydrocarbon chain. And so for that, it's more polarizable, being longer. I wish I had a more thorough explanation, but I don't. I'm very sorry. But I'm sure it makes sense. I hope it does. If not, just let me know and I'll explain it better if I can. We are moving on to the next question. All right. Now for the answer. Answer is hydrogen bonding, C. Circle, whatever. This isn't Kahoot anymore. I told you I couldn't get Kahoot going because it can only fit 10 people. Whatever. Onward. So ethanol has the structure CH3CH2OH. I don't have it drawn out here, but when you think about it, we have OH, and that has to do with hydrogen bonding. Hydrogen bonding is between hydrogen and either fluorine, oxygen, and nitrogen. And it's a relatively strong intermolecular force. It's not as strong as ion-dipole or ion-ion interactions. Ion-ion is obviously the strongest. And I even address this here. Ion-dipole forces are stronger than hydrogen bonds. But ethanol molecules, ethanol is a purely organic species, basically. There are no ions in it. And so if we were just have ethanol in a little container, the strongest force would be hydrogen bonding. No outside interference. It's just OH, that's the hydrogen bonding. Just remember, hydrogen bonds are between molecules too. It's an intermolecular force. I feel like I'm rambling too much. I'm terribly, terribly sorry. Terribly sorry. But yeah, just remember, hydrogen bonding is FON. F-O-N. It refers to hydrogen bonding to either of those three elements. Very large electronegativity difference and, very special kind of bond. I'm moving on. If anyone's been here from the very beginning, you all remember when every question's like 3 minutes long, 4 minutes long. Once you're past the first, the exam 1 material, it's not as time consuming. It's not as computation heavy. I'm sure that this feels a little bit nicer to go through, just as far as how much work you have to physically put in. All right, time's up. Now the answer for this is D square, and also known as beta emission. Now sometimes they'll say like beta plus emission, beta minus emission. I'm just going to take note of that right now. So beta plus emission is positron emission. Beta minus is beta emission. So if they say beta, just assume they're referring specifically to the negative every single time. I know that there's some ambiguity there, I just want to note that. If it says beta decay, it's beta minus. And so now if we have 2310 neon, that would go a little bit above the stability belt. It's closer to, the A to Z ratio is supposed to be closer to like, A to Z. That's mass over charge, I think. But anyway, number of protons, number of neutrons is supposed to be approximately equal protons and neutrons. Yeah, but if you were to emit a beta minus particle, I'm kind of representing it over here. If we were to emit a beta minus particle, we're going to be increasing the atomic number of the product by 1. Here's a little mathematical representation here. So we have the first species. And so once we emit the beta particle, 0 minus 1 e, electron, then we have to conserve the charge. And so to do that, this means that the product must have 1 extra proton. It must. And so from this, 12 neutrons and 11 protons sounds much more favorable now, does it? So before it was 13 neutrons, 10. That's not very nice. 12 to 11, much nicer ratio at this point in the, table. On the stability belt. That's the word, stability belt. Yes, Sophia. The difference between positron and beta decay. So with the positron, if you can see in the representation I have with AZX1 over there, if it were positron, I would have all of this, AX2, ZN minus 1 plus 0 plus 1 e. A positron is a positively charged particle with no mass. It's basically the opposing particle of an electron. And so electron, relatively massless. If we're just talking like whole numbers, it's massless. It's actually not. It's closer to 0. So electron about a mass of 0, -1 charge, positron, charge of +1, mass of 0 approximately. Does that make more sense? I'm going to wait till you will give your answer before I move on. Basically, positron emission is basically the opposite of beta minus decay, beta emission. I hope that makes sense. You are very welcome. I am ready to take everyone to the next problem. Okay, that's 3 minutes. Now, there's actually a very quick way to the answer, which is B, diamond. So, I'll tell you the quick way real quick. quick. So, beta minus decay, that's going to be increasing the charge by 1. Alpha decay is going to be decreasing the charge by 2. And once again, beta back up by 1. And so really, there is no net change in the charge of the species. It's going to be the same exact one, which is lead. And that gives us to B immediately. However, I'm going to work it out too. And so firstly, we have the first decay. That's going to be increasing the charge by 1, giving us bismuth 210. And now the second one, we have an alpha decay. That's going to decrease mass number by 4, atomic number by 2. And so that's where we get down to 206. And the species corresponding with atomic number 87 is thallium. And now third decay, beta decay once more. That's going to bring us back to lead 88. Well, lead 206, I meant. 88 is the atomic number. Is that good? I'm sure it is. But you tell me. Questions? All right, I guess not. In that case, next. Four minutes. We're going back to the lengthier stuff. All right. Now, time for the solution. Answer here is triangle. That's A, I think. Yeah. And so now, we're going to have to calculate the mass defect. Mass defect, that is the difference between the mass of the products and the mass of the reactants. So they gave this in the problem. And so now we have 134 whatever. Do I really need to read this all out to you? But yeah, basically, you just use the numbers that you're given, and you'll have to use the number of them. God, this feels infantile. I have to explain this now? Come on. But yeah, mass defects, difference between the mass of the products and the mass of the reactants. And you find that you're losing a mass of 9.219 atomic mass units. And now we're going to have to do a little conversion. This way we can get a nice units when we find the energy. And so atomic mass units to kilograms, and we get 1.531 times 10 to the negative 26 kilograms. And now to find the energy released through the fission reaction, we're going to have to do delta E equals delta M C squared. And so now just substitute. The speed of light in vacuum is 3 times 10 to the 8th meters per second squared. And so we find that we get negative 1.38 nanojoules. Now, there's a reason that the answer choice doesn't say negative 1.38 nanojoules. And that's because they're implying that energy is released in the reaction. It's fission. And so we're creating a lot of energy by getting rid of this, small bit of mass. Any questions? Oh, Jesus. Someone's home. Hopefully the dog doesn't bark. I'm going to go on to the next question now. This one should only take a minute and a half. Let me start the clock. Yes, of course. Let me type this out. What am I doing? Okay. That was a minute and a half. It felt longer. Sure. Now, the answer here is C, the circle in Kahoot, whatever, that I couldn't use, still salty. And so now, I know that some people like to use NT equals N naught e to the negative KT. However, there's a simpler way to do this. If we just think about what a half-life means. So when it comes to a half-life represents how long it takes for the mass of a species to be reduced by 1/2. And so after 2 half-lives, actually, it'll be reduced by half by another half. So 2 half-lives, it's 1/4. 3 half-lives, you're down another half, and so that would be 1/8. There's another way that we can represent this, and so I have it here. So the percentage of the starting material remaining be equal to 1/2 to the number of half-lives, exponent, multiplied by 100 if we were to use a percentage. And so if we were to do this with 9 half-lives, then we would find that we have 0.2% of the original material remaining. I'm doubtful that they taught it to you like this in class. However, if they were to ask something like this, it might be a very good way to just conceptually think about it. You're just thinking in terms of half-lives. It's quicker. I hope that some of you emerge with a different way of thinking and approaching some of these problems based on this review session. I am going to proceed to the next question. If you have anything for me, just let me know. This is a doozy. Okay. Now, if any of you, I'm sure a lot of people got this one wrong. It's B, Diamond. I will assure you that everyone has always gotten slaughtered on this question every time I've asked it. It's a very special one. It's dear to my heart too, trust me. So now for this problem, we are going to use our expression where nt equals n naught e to the negative kt. And so we're able to substitute for k. We have ln2 over t half-life, and that would be 22.3 years. So we have this multiplied by the time. That's our e to the negative kt part. All this multiplied by 7.5, we get 4.35 grams of lead-210 specifically. However, this is not what they were asking for. I'm sure you fell into that trap. I did too. This 4.35 is for lead-210. They're asking for mercury-206. And now, if we were to just do 7.5 minus 4.35, which is the lead-210, we get 3.15 grams. However, we're not done there, believe it or not. What you have to also consider is that we had some of the mass converted to a helium nuclei. We had alpha decay going on. And so now if you just convert the mass of the mercury-206, so it's mercury-206, 206 grams, and we had 210 over here. This is what we had originally. We're going to have 3.09 grams of mercury-206. I'm going to definitely open the floor to questions on this one. I'm going to move on to the next slide. If you're still writing your question down, I'll answer it in the chat. This one is also 3 minutes. Man, I can't believe our time is almost over. I'm going to be very sad when this is done. All right. The answer to this problem is D, square. And so now, oh no, they haven't given us initial product, or they haven't given us NT or N0. What do? There's a little workaround. We can use the rates instead and compare those. And so now we have ln of the rate at time t over the average rate. The natural log of this is going to be equal to negative kt. There's a little trick that you can do, by the way. So you can get rid of the negative by flipping the numerator and denominator in the natural log. And so now if we rearrange everything, we can get t is equal to ln rate naught over rate t, all divided by the expression for k, ln2 over t half-life, and we just substitute everything. And that is how we get 4,000 years. I'll give a few seconds for questions, and then I'll move on. Same thing where I'll just type it in the chat because latency is kind of a pain. Sorry about that. Okay, now organic chemistry. Not the kind you'll be taking in Chem 321, I'll just say that. This is very toned down. Very basic. If anyone here is taking the MCAT, by the way, I have a tutor that you can use. He's very good, very affordable, and really he's very invested in the success of his students, and his students tend to do very well on the MCAT. It's probably not something you're thinking about right now. You're still in Chem 131 or 129 and all, but, you know, it's good to have connections. It's good. Okay. The answer to this question would be D, square. And so now when it comes to these hydrocarbon chains, you're going to want to count the longest one first. I have this all numbered right here. So this is a 7-carbon main chain. And now we have some methyl and an ethyl branch coming from it. When we name this, we're going to want to prioritize alphabetically because at the end of the day, these are alkyl chains. They're, why am I explaining it like that? They're equal priority is what I'm saying. Alkyl chains all have equal priority. It's not the same as, like, let's say an alcohol or an amino group. Ethyl and methyl have the equal priority in terms of just, like that. It's confusing to explain it that way. But we're going to have to alphabetize them after we establish that these are alkyl groups. Yes. Once we can establish that these are alkyl groups, we are going to prioritize by alphabet. So ethyl, E comes before M, methyl. And so now when we number this chain, we're going to want to have ethyl as the lower number than the methyl. And so in this case, we're going to have 3 ethyl, 4, 5 methyl heptane. I think it's hep. Yes, dimethylheptane. Remember the di prefix. Man, I told you I'm ancient. I wasn't kidding. I'm a dinosaur out here. Now I am going to proceed to the next question. This one, I have a unique way to solve it. I think you're going to like this. Or maybe you won't. We'll see. If I can send out a Google Drive with all of my, what do you call it? With all of my PowerPoint slides, then I have plenty about organic chemistry on the finals one. There is some stuff that you guys have covered that I didn't cover when I was a TA. Like I see people talking about like ortho, meta, para. We did not do that in my class. So there are still some topics you're going to have to study on your own. I just want to be completely clear about that. What I'm going through right now is non-exhaustive of the topics that you may see on the exam, and they may not properly reflect the balance of topics and material either. Okay, time is up. So now there is a little trick to this, as I was discussing. And so one thing that I like to do is I like to consider first the main chain. And so they said that it is a 10 carbon chain when they said decane. And then we are going to want to account for the groups attached. And so they said that we have a methyl group, another methyl group, an ethyl group, and a cyclopentyl group. And so now that means that we are going to have 10 plus 1 plus 1 plus 2 plus 5 carbons. And so now we have a 19 carbon molecule. To get the number of hydrogens, we have to first consider, is this a completely saturated molecule? Are there no, rings, no double or triple bonds? So next, we're going to have to count for that. And so when we have a ring, we're taking away 2 hydrogens. And so if we have to take away 2 hydrogens, then we have, let me explain it this way first, actually. The number of hydrogens is going to be equal to twice the carbons plus 2. And then you're going to take away for double and triple bonds and rings. If you have a double bond, you take away 2 hydrogens. If you have a triple bond, you take away 4, because triple bonds have 2 pi bonds and double bonds have 1. You'll learn about that in organic chemistry if you're taking it. But we only have 1 ring. We have no double or triple bonds. And so the number of hydrogens is going to be twice the number of carbons. if we can agree that we have 19 carbons, there are 19 carbons, then there must be 38 hydrogens because we have twice the number of hydrogens compared to carbons. I know that this way that I'm explaining it might be a little bit foreign to you, but it's something that's going to prepare you for the future. This is certainly a harder level question, though. I will give that disclaimer. Any questions, let me know. I shall be progressing. We shall. We're almost there. I made this cute little structure in Oscar, by the way. If you're taking organic chemistry, orgo, and whatever, you shall be using this plenty. It's not that bad, honestly. I actually kind of liked it. Because I get to make stuff like this. It's nice. Okay, there we go. So the answer to this is A, triangle. This is an aldehyde. When it comes to aldehydes, it's going to be carbon double bonded to oxygen. And it's going to have that carbon binding oxygen double bonded. It's going to have another carbon attached. And it's going to have a hydrogen attached to it also. And so aldehyde, let me even show it again. So if we just look here, that carbon in that circle, that one right in the center, it has hydrogen attached, double bonded to oxygen, and it has that carbon in that ring too. That's how you know it's an aldehyde, that RCHO. It would be different if it had two carbons attached to it. That would be a ketone. And there's even two hydrogens attached to carbon and the double bonded oxygen. That would be called formaldehyde. But you don't have to worry about that. It's a fun little molecule. It's very unstable. We don't like formaldehyde. 1 minute for this question. And then a little pep talk after this, you know. You guys are almost there. If you stayed from the very beginning, you are an MVP. If you didn't, it's totally fine. I'm glad that you're here right now, listening to me rambling and talking about chemistry. Okay, we made it. By the way, if anyone is tuning into this stream after the fact, I would really appreciate if you fill out a feedback form too. I can send it to you if you just email me. You should have it in the group me and everything, or the announcement, but it would be... Oh, what's going on here? Do not disturb turned off. B, ketone. I was actually talking about that right before we got to this question. So ketones, they have the carbon double bonded to oxygen, and they also have two carbons bound to it as well. So I have it R1COR2. The others that they listed here, we've got aldehyde. We went over that last time. We have alcohol. Alcohol group is ROH. Carboxylic acid is the carbon double onto oxygen. It has an OH attached also. And then it has a carbon attached to it as well. So yeah, we made it. Now, how did everybody do? If you're comfortable sharing your score in the chat, like X correct out of whatever, go for it. To give a little disclaimer, from when I have given this presentation in the past, some of the people making the top 5 only had like 40 questions correct, and there were a bunch of people in the low 30s and the high 20s, I'd say. But I would say that if you did very well on this practice, then I'd say it's decently reflective of your potential for the final exam. I definitely included some very challenging problems in here. Very challenging. Some of them you're probably not going to see. If you didn't do so well, a couple of things. Firstly, there's still time. There's still time to improve. And B, kind of what I just said earlier, there were some harder questions in here. Definitely have some reviewing to do. Understandable, but now's the time. It's not too late yet. You can still do it. I don't know if there are some of you here who are trying to pass the class, but if you're here today or you're reviewing this right now, then I'll assure you that you're one of the people who care about your success. I'll assure it. And, I'm sure that everything will work out in the end if you just put in the effort. Like I said earlier, you're not going to try so hard and get so far. In the end, it won't even matter. You're going to get there, okay? I believe in you. I've never been the best at motivational speeches. This is getting kind of redundant. But if anyone here is interested in becoming a TA, definitely stay in contact with me. I can just, give tips. I can share these resources for you to pay forward someday. And everything. And once again, if you have an interest in taking the MCAT in the future, I can give my tutor. And really, if you need any additional help, until your final exam, I'll be here for you. I remember when I was a TA back in the spring, I had a student. She would come to my office hour every single day. She was having trouble in the class. I always made myself available, and she did it. She put in all the extra effort. She did everything she could. She used her resources. You've got to do the same thing. And I'm telling you now, I'll be here for you whenever until that exam hits. And even after the fact, keep in touch. We all need our mentors in life, Very helpful? Yeah, of course. And not a problem. I wouldn't do this if people didn't appreciate it and if I didn't enjoy it. Please tell me how it goes after the fact, please. If you do well, that's pretty fantastic. If you didn't do well, you tried your best. Really, you should only truly be ashamed if you didn't try at all when you think about it. Because, one of those regrets that you should have is just like when you don't try something, when you don't put in that effort. Yeah, you have my email in GroupMe from the announcements. If you ever need anything, GroupMe also. And yeah, this was a lot of fun. I'm glad that everyone tuned in. Best of luck. Please keep me updated.